Welcome to today's deep dive. We've got a really fascinating stack of sources to go through today. So, developer notes, open source repository readmes, and Andrzej Karpathy's recent architecture essays.
Yeah, it's a great lineup. Lots of ground to cover.
Right. And our mission today is to figure out how to give AI agents continuous compounding memory. Because, working with an AI coding agent right now is kind of like having this brilliant colleague who suffers from severe amnesia.
Oh, absolutely. I mean, they can solve the hardest engineering problems today, but then tomorrow you have to re-explain the entire code base to them from scratch. It's incredibly frustrating.
Exactly. And you just end up losing all that rich context across different projects.
Well, to fix this, we have to fundamentally change how these models process information. We really need to move away from standard RA, retrieval augmented generation.
Because RA is basically just having the AI search through raw, unstructured text at the exact moment you ask it a question, right?
Yeah, exactly. Which is, I mean, it's the equivalent of forcing a human developer to reread the entire source code of a massive project every single time they need to fix a tiny CSS bug.
Oh, wow. Yeah, that is incredibly inefficient.
Oh.
So this is where Karpathy's compiler analogy comes in and kind of changes the paradigm.
Right. Think about how a developer compiles raw C++ code into a fast executable application.
Hmm.
Karpathy argues we shouldn't force an AI to read raw documents at runtime.
So instead, you use an LLM to pre-process, or I guess compile that raw data into structured, dense knowledge artifacts, like an internal wiki, basically, long before the user ever even asks a question.
Exactly. And because the data is already organized like that, you drastically lower the chance of the AI hallucinating.
Which is huge. And it doesn't even need to search a massive, complex vector database anymore, does it?
No, not at all. It can actually navigate using something as simple as an index.mnd file.
Right, which is just a lightweight text file that acts as a visual map of the project's architecture. By compiling the knowledge beforehand, the AI already knows where everything is.
Exactly. But applying this to a live coding assistant requires capturing context on the fly. We aren't
Yeah.
compiling external internet articles here.
We're compiling the agent's own internal interactions.
Right. Exactly.
So if Karpathy's architecture solves the theory of compiling data, I mean, capturing that live context while a developer is actually typing code is the next hurdle. Like, how do we snag those insights without interrupting the workflow?
Well, we use Claude Code's built-in hooks, specifically the precompact and session end hooks.
Okay, break that down for me. How do those work?
Sure. So a precompact hook triggers automatically just before the AI's short-term memory, its context window,
Oh,
fills up. It basically intercepts the chat, extracts the crucial decisions, and saves them.
oh, that's clever. And then the session and hook captures a final summary when you close out.
Yeah, precisely.
Yeah.
It's essentially taking its own meeting notes before it forgets what was said, and those transcripts become daily logs.
Which are then periodically flushed and compiled into that cross-referenced wiki of coding patterns we talked about. But wait, I actually read about developers trying to build this exact thing, and it completely broke down.
Oh yeah, the early attempts were definitely messy.
Right, they set up these fragile background sub-processes to manage the compiling, and the second a developer closed their laptop lid, the process died and just corrupted the memory.
Yeah, early adopters definitely over-engineered it with massive, brittle automation pipelines. But the solution, which we actually see in tools like the open-source Claude Memory Kit, is adhering strictly to Karpathy's rule of simplicity.
Meaning no complex background servers.
Right, exactly. You just use minimalistic, lightweight scripts to handle the pipeline.
Ah, so simple commands that only execute locally exactly when the hook fires.
Right, which makes the whole system entirely crash-proof.
Okay, but even if the scripts are crash-proof, code bases are constantly evolving. So if the AI is just endlessly stacking up these daily logs in its wiki, wouldn't it eventually become a chaotic mess?
Like full of stale or contradictory information? Yeah, it would, if it didn't perform LLM linting on itself.
Linting. I mean, linting usually means running a program to analyze code for potential errors.
Exactly. But here, the system analyzes its own memory. It draws on Zettelkasten-style AMEM systems. And Zettelkasten is simply a method of linking decentralized nodes together.
Oh, interesting. So the agent regularly scans its own memory repository.
Yeah, it actively looks to find and fix broken links or resolve contradictions based on its new experiences.
Wow, it's like an automated copy editor that just reads through the AI's diary every night.
That is a great way to put it, yeah.
Or like a garden that autonomously pulls its own weeds and plants new flowers wherever it finds a gap. It just
Hmm.
crosses out outdated facts, merges duplicate entries, and links related ideas together.
Right, so the underlying story stays perfectly consistent and you don't have to manually manage its files.
Mhm.
It creates this interconnected knowledge network that continuously refines its own understanding.
Which is incredible because by combining Claude Code hooks with a compiled knowledge architecture, your AI agents automatically accumulate, refine, and reuse knowledge over time.
Yeah, it truly transforms the AI from a stateless tool into a compounding asset.
It really does. Which leaves you with this provocative thought to chew on today. If your personal AI agent continuously compiles its own lessons and systematically evolves its memory from every single interaction you share with it,
Yeah.
at what point does your agent's unique compiled experience become more valuable to you than the multi-billion parameter foundation model running it? Because that amnesiac colleague might just become your most irreplaceable partner.